All right, well, I think we are live, and thanks for joining in for another session here of FE Civil Review 2022. And tonight we actually have a kind of like a double header, so we get to talk about topics 2 and 3 on the exam. So the first is ethics and professional practice, and the second here will be engineering economics. So it's kind of cool. We kind of get 2 for the price of 1 in this session. And I skipped over these in the beginning. I started with statics, and I kind of jumped in. I'm sorry. I started with math, and I kind of jumped over these topics. And part of that is because they're a little less technical, and statics is like 100% super applicable to everything. So I wanted to start there. But hey, Sammy, good to see you here. Good to see your presentation earlier too. That was awesome. So. We're just going to jump in and get going. I think I'm just going to jump in and do ethics first. It's a little bit more just kind of discussion based, so we're going to talk about this. I teach a course where we talk about engineering ethics, and the number one thing that we talk about all semester long is an engineer's number one importance. They have to hold paramount in any ethics code that you look at is to hold paramount the health, safety, and welfare of the public. So that kind of undergirds everything that we're talking about here with engineering ethics, with professional practice. And professional practice gets a little interesting because licensure is state dependent. So I'm in New York, and New York is, one thing. You might be working in New York, you might be working somewhere else, and each state has their own specific laws that you'll have to comply with. But NCEES, what they do is they kind of give a model law, right? So they give a model code of ethics, they give a model law for professional practice. And I would suggest you go into the reference handbook and you read that. So I'm just going to come back up here, and I was on engineering economics, but if you come into the section with the code of ethics, it's not super long. So we're going to start here on what page 4, and if I just start skipping pages here, it's 5, 6, 7, 8, 9, 10, 11. So this is like 11, 12 pages of reading, and I would suggest you just take the time to do it, right? So we're going to go over some questions. We're not going to hit every line of this, but it's like an engineering contract. You have to actually read the whole thing to know the whole thing, to know what's applicable and what's not. So we're going to hit on some of those topics that maybe I ran up against in professional practice, and not, exactly. We're going to use some NSPE case studies, which the engineering code of ethics that the model law puts out here is kind of based somewhat on that. So we're gonna look at some of those cases. I'll give you references if you want to go actually see what NSPE has to say about the cases. So I kind of like that approach, just to look at some of these questions, to look at some of the big ticket items that I think you might be seeing on the test. But the big kind of important thing with ethics is just to go through this and to read it, to kind of understand what's in it. So that when you get a question on it, you kind of have an idea. Okay, I've seen that before. It's in here. I can search and find the specific wording maybe that's in the question, but hopefully you have some background there as well. So let's just jump into problems here, and we'll just get started. So with the code of ethics questions, I did put some of those alternative question types. So you actually do have to read the different pieces. And the reason I did that was that there are some nuances. With ethics, you'll see in a couple of these questions, sometimes there's more than one option that's ethical, right? And that's reflected here, especially with those multiple, fill in the blank or checkbox type questions, which the FE now has. So the question here goes, a professional engineer, and this is kind of at the core of a professional engineer's duty and responsibility, is to do professional engineering in a responsible way, right? So professional engineers, at the core of what they're doing, should be taking responsibility for their drawings, doing good designs, doing designs that protect the health, safety, and welfare of the public. So the question here goes, a professional engineer is the principal and an engineering company has multiple designers and engineers working on a project. So you're the boss. Well, let's say this engineer is the boss. Maybe you're not the boss yet. You just got your license, right? But let's say there's this principal oversees a group of people that is designing under the boss, right? I mean, you only have one boss, right? And maybe you want to be that boss someday, and maybe you will, okay? But they're working, they have multiple people working on a project based on the model code of ethics, right? So that comes from, again, here. We have a model code of ethics that's in the FE reference handbook. Again, you want to read through this. There are rules here. the question is, select all the instances where it's appropriate, where it's okay, where it's acceptable for the engineer, for this principal engineer, to sign and seal plans associated with the project. And I'll probably find typos in here. I'll probably do a quick update after this, but to sign and seal plans associated with this project. So, can the engineer sign and seal plans he personally prepared and where he did the design? Absolutely. That's the number one place where engineers are responsible to do or to stamp drawings, right? Because if we come to the model law here, and I zoom in a little bit, you can see hopefully, man, there's different pieces of this, but what are we looking for? Well, just before we even get started, let's just look at that core number one on the list, right? What's the first and foremost responsibility? To safeguard the health, safety, and welfare of the public, right? So engineers, number one responsibility, and right underneath that, sign and seal only those plan surveys and other documents that conform to accepted engineering and surveying standards. So if they don't, if they don't conform to those standards, you can't sign them. But hopefully they're doing you as the engineer are reviewing the work that you're doing, and you know that it conforms to the accepted standards, and you're signing those documents as such, right? There's other things that go in on here, but we could also do like a seal, right? Sign and seal. Does that show up? I think it does. Let's double check here, right? So just that quick search and find, you can see licensees not affix their signatures or seals to any plans or documents dealing with subject matter in which they lack competence. Okay, licensees may accept assignments, responsibility for coordination of an entire project if each segment is signed and sealed by the licensee responsible for the design. So even if you're a head designer, you can have people working underneath you, but those people that are working underneath you should be signing the work that they do. They should be competent and acceptable to do it. So let's come back here and look as well, but let's go to the next one. The engineer may sign and seal plans if the design was developed by employees of his firm, if a general review is performed. And this is where it gets tricky, because basically in order to sign and seal the drawings, you need to be responsible for those drawings. Okay, so I'm just going to keep searching here and keep going on and keep looking here. Actually, let me just come back once here. Only those plans document conform to the accepted engineering surveying standards. This is the licensee's obligation to ensure that. But a general review generally isn't enough to get there. Okay, so let's see what else it says about seals. A symbol, a list image. Okay, let's keep going. Is there anything else with seals that we need to know about? Not so much. I mean, this is the model for disciplinary action, right? And basically, what else? It's signing, affixing, permitting the licensee's seal or signature to be affixed to any specification, report, drawing, plans, plats, right? But basically, where surveys or revisions thereof have not been prepared by the licensee under the licensee's responsible charge. And this is one of those key phrases, the licensee's responsible charge. So when you come back to this second option here, if you're the head boss and they're developed by your employees, but you're not the responsible one for that design, in other words, like the people doing the actual design are not you, and you're not directing them kind of how to do it, and you're just doing a kind of a general overview, technically you're not supposed to sign the drawing. So unless you're actually in charge of the people underneath you, in the sense that you're directing the design and how it gets done, and you're doing a detailed review, I'd say you're not supposed to sign the drawings. And there are some references down here. One of the things that I love about NSPE is they provide a lot of detail with their Board of Ethics and their reviews, so that you can go ahead and you can click on some of these and you can read and get into the kind of the nitty gritty of how they actually work this out. But I'm going to say a general review here, especially, I'm going to highlight that the general review is not enough, right? But let's look at this next one. Okay, the engineer may sign and seal drawings prepared by other professional engineers, right, that are working under direct supervision and responsible charge and are reviewed in detail, right? So this is now you are the head engineer, you're overseeing a team of engineers, you're directing the design, you're reviewing the design, you're overseeing all the design, and you're stamping those drawings. And I would say that's acceptable. Right, there's a difference between a general review and a kind of a general review or a cursory review here, and a detailed review. Okay, but again, there's that responsibility. If you're above them in a responsible way, and you're doing that detailed review, I think is critical there. Okay, what about this next one though? The engineer may sign and seal plans prepared by other unlicensed designers. Can you sign and seal something by an unlicensed that maybe an unlicensed designer worked on? Well, technically, where's the crux here, right? The crux of it is, are those people working under your direct supervision? Are you still are you still kind of in responsible charge of them? And are you reviewing everything in detail? So, for example, I once delegated a beam design to a junior engineer. He had passed the FE. He was doing work. He had excellent calculations, right? And I delegated kind of a design portion to it, but I still had to go through all of those beam calculations in order to make sure that I was happy with those beam calculations. And actually I found a mistake, right? So I found a mistake in what he was doing, and that's kind of the level of detail. Are you reviewing it enough where you can actually go in and own those calculations for yourself, right? And this is where you're essentially doing the design, but you're directing someone how to do it, how to maybe do the CAD piece of it, maybe how to write a certain piece out even, but you are the one making the decisions as the engineer. I'm gonna say that's still okay. Okay, let's keep going. But again, this is direct supervision, responsible charge. You're reviewing them in detail. You're not just passing things off and just accepting, well, they're pretty good. They went to a good school. They passed the FE. They're good. No, you have to. You are still, as the engineer, are the one that's taking the responsibility here, and you have to review in detail. Okay, let's look at number 4 here. The engineer may, or no, number 5. I'm sorry. The engineer may sign and seal drawings for coordination of multiple disciplines if each technical segment is signed and sealed by the licensee responsible for the respective technical segments. And that actually comes from the model code here, right? So the model code says if you're kind of coordinating a job, you can coordinate the job and sign kind of a bigger picture. But if you have, 4 engineers working underneath you, each one of those engineers is signing their own piece of the work, right? So this is where they're accepting a responsibility for coordination, and that is okay per the model code. So this one I'm going to say is okay as well. And the engineer may sign and seal designs prepared by other licensed engineers as the design engineer in responsible charge. And again, unless they're doing that review, unless they actually have design input, I'm going to say no. Just because the licensed engineer is doing it doesn't make it okay unless you're actually under the supervision of that person and actually doing the work. So I don't know, maybe you have differences of opinion on this. Maybe the Board of Ethical Review would look at this and be like, some of the wording in there is a little tough, but that's where I'd say I'd point you actually back to NSPE, and I'd say go look at what they have to say. Some of these links here, they give you. I'm not gonna copy everything that they've given in there, but I will reference them because they give you the actual determinations of what they consider ethical. And NSPE is a good one. There are some other standards out there, but that's what I'm using here as a basis. So that's where I'd go with this one. Maybe again you might think a little bit differently, but let's keep going. But the key of this, right? The key of this is you have to be responsible for the design, responsible for design decisions, and reviewing things in full detail. Okay, let's go to question number 2. An engineer is retained to perform an inspection of asphalt on a bridge. So let's say they're doing a deck replacement or replacing or putting down a new wearing surface or something like that. During the inspection, the engineer notices a potential defect in a structural wall. So you got a wall here along that side of the bridge, And basically, this may have contributed to a fatal accident that occurred previously. So previously in the past year, there's a fatal accident on the bridge, and this engineer notices something that says, hey, I'm doing an asphalt inspection. I'm qualified to do an asphalt inspection, but this thing looks a little weird. Man, I'm going to put it in my notes. Note it in my, the field book, and then notifies the client. Hey, Mr. Client, this is a defect that I think could have maybe had an impact on that, something you might want to look at. The client notifies the public agency that owns the bridge. At the request of the public agency, the engineer does not include the information about the wall in his final report on the asphalt inspection. Right, you got hired to do an asphalt inspection, and that's what he's qualified for. So, but the engineer does not, or the engineer does retain the information in his field notes, right? So, which of the following statements best captures the ethical consideration presented, right? And this is where it's kind of one of those things where you have to kind of look at the nuances, right? Here, the engineer, we can say the engineer question, or response A says the engineer acted ethically as the defect was raised. So hey, I'm seeing this, I'm wondering about it. I didn't do a full analysis of it. I'm here for an asphalt inspection, but you might want to look at this. So they raised it to the parties for further consideration, but was not included in the report since it was speculation. It was not based on actual design calculations, testing, or evaluation by a competent professional. We don't know that an asphalt inspector is going to be competent to actually evaluate a structural wall, right? Maybe that person's a structural engineer as well, but unless there's that competency there, they shouldn't be practicing in that area as well. So I kind of like that answer, but let's look at the other ones. The engineer acted ethically to notify the agencies, but unethically because they didn't include this. I mean, this could have been a defect. It could have problems. If you don't put it in the report, it may not get evaluated. Okay, that's another option. Let's look at part C here. Response C says the engineer acted unethically by not performing further analysis. So you see something, you're tied to and responsible to do it. Well, not necessarily. I mean, there's a lot of things you see, and you can speculate a lot about different things, but it doesn't mean you're responsible to go take care of them. Maybe you're responsible to raise it to people, but you're not necessarily responsible to just pick up everybody's problems just because you have the name engineer. Okay, there's a subtle difference there, but you have to make sure that you raise problems where appropriate. But not necessarily take responsibility for everything that could go wrong. And then the last one here, the engineer acted unethically since ignoring the potential defect and leaving it out of the final report could jeopardize the health, safety, and welfare of the public. The engineer has an obligation to document the potential defects, right? And again, this is where you have to be really careful. You have to only practice in your area of expertise. So if you're an asphalt, if your expertise is transportation engineering as an asphalt inspector, maybe you're not qualified to do a wall, and you shouldn't really be messing with walls because you don't have that expertise. And this is where it gets subtle too. But I'm going to go here actually with response A. I'm going to say it's ethical because the engineer raised the problem, right? He raised the problem. He told the parties that needed to be told of the potential concern. But again, recognizes, hey, I'm not doing a full evaluation of this, but it's something you might want to look into. Right, documents it, keeps it in his own field notes, but it's not really part of an asphalt inspection. So, that's where I'm going to go with this. There's a similar case that NSPE did, 9713, a duty to report unrelated information observed during rendering of services. So, there's kind of a duty to report it, but not necessarily a duty to see it through, if that makes sense. And there's a subtle difference there. You weren't retained to do a wall inspection; you're retained to do an asphalt inspection, right? There's a duty to report it, but then it goes back to the agency kind of to do next. Okay. Well, let's keep going. Okay. So yeah, the specialization matters. What you were hired to do matters, right? But if we go back to the Hyatt Regency, right? So there was a peer reviewer that was hired to check the connections, right? And what did they do? They checked some of the connections, but not all of the connections. And when they were asked, right, even in the Hyatt Regency here, they were asked, did you check the connections? They said, oh yeah, we checked the connections. Well, guess what? Hyatt Regency, what happened? One of the connections failed, and over 100 people died, right? And then when they were asked about it, they said, well, did you check the connections? And they said, well, we checked some of them. We checked, but we didn't have time. We didn't have time or money to check all of them. So there was this expectation that they had checked all of them when they hadn't, right? And that's where you have to be really careful. If you don't do it, you have to let somebody know that you didn't do it. And that's where, like, that was one of the big things that came out, even at the Hyatt Regency. It's the idea here is, if you're going to do work, do it. And if you're not going to do it, tell somebody that you're not going to do it. Okay, and that's where you have to be careful with what you do, what you don't do, but you have to also make sure that you are telling people what you've done and what you haven't done. So I think that's probably the bigger piece of it. So again, this is where ethics can get gray and it can get a little interesting. So you have to definitely take a look at some of these in more detail. This one's kind of interesting. I saw this one in the age of accepting things, in the age of cell phones, where you can waste time on your cell phone at work and cheat your employer because you're doing personal stuff on work time. I thought this one was interesting. This actually is based on an NSPE case that actually came up, and what happened was there was an engineer that's retained to perform a routine mine inspection. Upon arriving at the site, the engineer realized he forgot his safety boots. So no steel toe boots, but they're required on the site. You can't enter the mine without steel toe boots. So what do? Due to the nature of the remote site, you can either, let's just keep going. Due to the nature of the site, the mine company routinely provides visitors with required PPE, including boots. Right, so this is something that the mine is prepared for, and the engineer, though, recognized that accepting the boots will violate his company's code of ethics, since the company prohibits accepting, his firm prohibits accepting gifts that have a value of more than $100. So, is it ethical for the engineer to accept the boots? So this is one of those ones where there's a number of answers that are good, but what I want you to do here is select all the following approaches that would be considered ethical. So is it ethical to accept the boots? This first one here. Is it ethical to accept the boots, but not notify your employer? I mean, like, it's maybe they're $150 boots. It's nominally more than $100. Not a big deal. And by accepting the boots, you save everybody time and money, because you don't have to waste everybody's time by going back, losing a half a day or a day's worth of work to do the inspection and getting your boots. So it's a wash. We're not going to worry about it, and we're just going to get along and be happy. Well, honestly, I don't like that. There's a policy, right? There's a policy for a reason, and I'm going to say no, not good. Okay, but is it okay to accept the boots and notify your employer? Honestly, I think it is. And at this point, it's like, you notify your employer, and if the employer has an issue, you can pay for the boots, you can, make it right, but just to be upfront. And honestly, that's where there's some latitude kind of a little bit here as well. It's like, if you can have that forthrightness, if you can pass the newspaper test, if it was published in the newspaper, published online, if somebody tweeted it out, you'd be okay with it, right? And that's where, okay, I'm going to accept I'm going to go over the $25 to keep everybody going. And why is that? Well, the reason, one of the reasons, let's come back to even the code here, right? One of the things that licensees are supposed to do is they're supposed to act as essentially faithful. Let's look here. They're supposed to be, let me just search it. Faithful agents. So normally there's like a faithful agents in here. Is it not in here? Oh man. Let me try faithful. Let me just look here. I'm just curious if this shows up in the model code. No functions fully. Those are not faithful. So typically there's a section in that, like the NSPE code, for example, that says, let me read it to you here, and let me just look to see if it shows up as well where we can find it here. But let me just find it here for a second. I've got it. In the NSPE code, essentially what you're supposed to be doing is you're supposed to be acting as a faithful agent or trustee, right? And you're supposed to conduct yourselves honorably, respectably, and those types of things. It's just, this is where you want to act in a manner that's above board. You want to act in a way that everybody's on board with what you're doing, that you're not taking bribes, you're not taking payments under the table to as a conflict of interest. I mean, this is not a conflict of interest here. Honestly, if in anything, it's something that is going to help the relationship. It's going to help everybody move along, because it's making things work. It's making things work for everybody. And yeah, is this gifts? So that's a good question. Let's look up gifts. Okay, license shall not offer, give, solicit, receive any commission or gift, other valuable consideration in order to secure work, and shall not make any political contributions with the intent to influence an award, right? So I mean, again, we're not doing anything that's accepting something that's super egregious here. Is it a little bit crazy to say, like, we're gonna waste a day's worth of everybody's time because I forgot my boots? I think it is. Honestly, I think that's where, if we come back here, I think this is okay. Personally, as long as you are upfront with everybody and you notify your employer. And if you need to, you pay for them after the fact, right? Same kind of thing here. Can you use the boots and return them? Sure, why not? Right? They're not your boots. It's kind of like somebody's lending things out for you. Do you need to notify your employer if you use the company's PPE? Probably not. But I mean, it's in full disclosure. I'd say it's probably not a bad thing to do either. Is it ethical to decline the boots and postpone the inspection? Honestly, it is. I mean, and that's one thing. If you go to the NSP Board of Ethics, they have a similar case in here, and they say it is actually ethical. If you have a, man, this is rough. I don't want to violate my company's policy. I screwed up. I'm going to eat this day. I'm going to report to my employer that, hey, I probably shouldn't even be paid for this day, or I'm going to go do other work, and we're not going to charge you for this time. Then yeah, let's do that and make it work. Okay, there's some assumptions you have to make here, but I'm making some of those as we go. Let's look. The engineer is not obligated to disclose his forgetting his boots and should postpone the inspection. Honestly, if you're not disclosing this, the reason for the postponing inspection, I don't think that's being a faithful agent. I think you need to own it where you screw up. Personally, that's my opinion. Maybe I'm wrong, but that's my opinion on it. And lastly, engineer should proceed with the inspection for the safety boots. Why is PPP for you important for everybody else? The reason this one's bad is because your safety impacts the safety of others. Do you catch that? So if let's say there's a boulder or something falls on your toe and you can't walk out of the mine, what happens? Guess what? Your safety now is dependent on other people to get you out of the mine. So your safety is important. You can't just forgo your own safety in order to make things work. So that would be considered unethical. So I don't know. Let me know what you think. I mean, again, these are crazy, but hey, Kyle Long, congrats. That's awesome. I'm so glad you passed. I'm glad this is helping you, and I hope it helps others here as well. But who knows? We got ramblings on ethics, and then we'll get into economics, which is fun too. Engineer A was the primary engineer with direct control for a design project at firm X. So engineer A is in charge. He's doing this. He's got control over. He's making the decisions. But then he finds a better job. Could this happen? When the project's in final review, essentially complete. So it's like, they just did, they're 95% complete. They have a couple little details to finish up. He leaves to work at firm Y. So he's done all the design so far. He's been in responsible charge. He's been directing everything, making all the decisions. Prior to leaving, engineer A did not sign or seal the drawings. I mean, they weren't complete, right? So he's not going to sign things that aren't complete. But what happens? Principal from firm X asks engineer A to sign and seal the drawing. So now, this engineer A is working at some other firm. He's working at firm Y, right? But firm X comes back and says, hey, will you sign and seal those drawings for us because you're the engineer in charge? Well, okay, is it ethical to just ignore the request and say, sorry, buddy, I'm no longer at your firm, and you can go deal with it. Too bad. Okay, is it ethical to refuse to sign and seal the drawings and basically just say no, right? I mean, well, the first one is just ignoring. The second one's saying no and just being, out there with it. The third one here is saying, I'll do it, but I need a little bit of time. I need a little bit of money to just finish up those last little few comments. I'll do a few comments. I'll give you my final design and be done with it. Or the last one here, let's just take the contract and bring it over to my firm, right? I mean, you guys didn't do the design. It was me. It's my design. I should have it at my firm. Honestly, I think the best course of action, and the one that's kind of similar to what the NSP would say would be to, like, if you want a nominal fee, like a hourly rate maybe to finish up the drawings, this is reasonable. But like, again, in that disclosure of kind of acting as faithful agents to the client, to the firm, to who you worked with, even your former employer, right? You should, as an engineer, be a faithful agent trustee. You should not be disclosing confidential information. So you shouldn't be disclosing the information you did at your old firm to the new firm. Okay. What else? You should accept responsibility for your own professional activities. And again, this is where those model codes come in and say some of these things you need to accept responsibility for your work, right? You should be signing and sealing the work you do. You should be taking responsibility for it. If you need a nominal fee to do it, because you need to look at those last few kind of details there to make it not just essentially complete, but complete, that's reasonable. Okay? So, oh, Jason Crandall, man, I love you. Well, it's so good to hear from you. Don't like love you. That would be weird. But love your video too, man. Love your interview. So good to hear from you. All right, that was awkward. Let's just keep going. Question 5. Experience requirements that must be satisfied for individuals seeking professional licensure typically include all of the following except. Okay, so basically there's 8 years experience from associate's degree, 4 years experience, bachelor's degree, 3 years experience, master's degree, and 2 years experience, a PhD. So now we're kind of getting into licensure. And here, again, we have some of these obligations. I'd just say, I can't go over questions for all of these. I don't have time. But what you should be doing is reading through this to kind of get into some of these pieces here and take a look at it. So here, if we get into this, this is where we have model laws here as well. But there's some definitions, what the practice of engineering is. There's also some education requirements typically that are set forth here. And where do they show up? They show up down here, licensure as a professional engineer. So what we're doing here is we're saying typically what is required is to become a professional engineer, to become a PE, you should have a degree in engineering from a bachelor's program, a master's program, or a doctoral program. And what else is there? Are there time frames here? I want to say I thought there were time frames. And here's PE experience requirements. So master's degree, okay, is 3 years. Earned doctoral degree is 2 years. A bachelor's degree, where does it say it should be? It should be 4 years. 4 years of progress. So where do you see associate's degree? You don't. You don't see the associate's degree. So previously, actually in New York State, until last year, associate's degree people could get associate's graduates could get a license if they completed 8 years. So last year in New York, that changed to require a bachelor's degree. And actually, this is where it's a little weird because state by state, some of those requirements are different. But on the FE, you have to know what the requirements are for the FE. So the FE isn't really a state; it's just an FE. It's made up, right? So what we're doing here is we're saying we gotta look at these but essentially this one is the one that this is the exception. You cannot, according to the FE model law, get your license if you have an associate's degree. You have to go on to get that 4-year degree. Okay. So again, state by state, it's a little bit different, but what I wanted to use this question for to point out was the idea that in the FE, there's this own model law. So it doesn't matter what your state does, it matters what the FE says. And that's where you have to understand what's in the reference handbook. So May the 12th and May the 4th be with you. Sorry, I just had to. It's you know. So Sam, you ask a great question. 6 years for bachelor's. And this is where this also comes into EAC ABET versus ETAC ABET. There are states like New York and a lot of New England that allows engineering technology to get licensed. And if you're in an engineering technology program, typically it's going to be 6 years. So that's where it comes in for you, I believe, is you have the 6 years in New York based on the engineering technology degree versus engineering science degree. So there is a push to try to equalize that. It's interesting. I read something at one point that said some of those discrepancies are actually kind of even Jim Crow era, which is kind of crazy that some of those laws are still around that have discrepancies in the way things are. But that's where it's at now. So you have to check each state. But for the FE, you have to know what the FE says as well. So that's where it comes up in the FE. So yeah, that's it. You know, that's the thing. You can get a raise as an engineer because you have a PE after your name, even if you're not practicing as an engineer. Like, for example, you get the PE in New Jersey, but you're working in New York. But you're not actually you're not practicing engineering. You just, it's the way sometimes that works. So, yeah, Jason, that's something out there as well. So let's go to this one. The profession of engineering. This is the profession of engineering, right? This is, engineering is a profession, and what makes a profession a profession? Well, there's specialized what? There's specialized knowledge, privileges, responsibilities, and I almost put in here superpowers, but man, I had a hard time with that one. Yes, you need specialized knowledge, right? So this background, this education, you get privileges, you have the ability to stamp drawings and basically allow buildings to go up or things to be constructed, but you don't have necessarily superpowers, okay? So, do you have special responsibilities? Yes, you have a special responsibility. The other thing that I wanted to point out with this one is actually, as you read, even the basic, when we start here, engineering is considered to be a profession rather than an occupation because of several important characteristics, right? And basically, we get here. It's similar to law, medicine, theology, specialized knowledge, privileges, and responsibilities. And this is one of those where the answer is right in the text, and all you have to do is go ahead and put it in here. Okay, so if you can search those words, hopefully you can find them and make it work. But I don't know. That's where we can go from there. So actually, just thinking, Mike, Noah, Sammy, when you guys pass, let me know. We'll do an interview. We'll throw it on the channel for you, and we'll tell people what you did to study. Okay. So let me know, and then you can make your video better than Jason's. All right, licensure. Obtaining a professional engineering license in a given state indicates which of the following. I kind of like this question because it sort of gets to the heart of the issue. What does a professional engineering license actually mean? Does it mean A, that you're minimally qualified? Does it mean B, you're an expert in your field of examination? Does it mean you may accept professional services if you're insured for them? Does it mean you're qualified to perform the assignment provided by your employer? Which one of these? And man, I wish I could just do polls here for you, but the right answer, at least the right answer that I think is this, that just passing your PE means you're minimally qualified. Is that deflating or what, right? But I mean, if you think about it like this, what's the PE? It's the minimum bar you have to pass in order to be competent enough to basically have the state entrust you with lives of other people, okay? This is great. I love it. So to become an engineer, to pass those tests, those are the minimum qualifications. You are expected to go above and beyond them, and as you gain experience, you will go above and beyond them. But the tests are the lowest bar, right? Just because you get a license doesn't mean you can only practice for things that you're insured on. I mean, you can practice for things you're not insured on. It's not a good idea, but you can do it, right? You can. You're not going to necessarily be qualified to perform every assignment, right? If you're, again, going back to the asphalt, if you're an asphalt engineer and your boss gives you a structural project, you say, hey, I'm not a structures guy. Does that mean you can't learn it under the direct supervision of somebody that's in responsible charge? No, you still can learn that, but you need to be doing it under the direction of someone else, right? So this is not, you're not just magically qualified to perform every assignment, especially ones that aren't in your area of competence. So minimum qualifications, that's what the PE means. All right. So let's keep going here. Question 8 says, a state licensing board could revoke a professional engineer's license for which of the following? Man, so evidence of alcoholism, defaulting on a home mortgage, so you essentially go bankrupt and you lose your house, it gets foreclosed on, issuing public opinions based on facts, or running for political office. Which one do you think? And this is where it gets kind of interesting, but if we come into the Code of Ethics, again, there are disciplinary actions in here, and we can take kind of a look at that as well. But model law, general requirements for licensure, we can keep coming down here. Grounds for disciplinary action. So fraud in obtaining your license. So don't lie. If you haven't done your PDHs or your professional development, don't say that you have. Okay. Negligence, misconduct. Obviously, if there's gross negligence and people die because of your actions, you could lose your license. What else? Plea of guilty or null condemnatory for a felony. So if you have a felony, right, that is an issue, and you have to report it and deal with it. A for alcoholism. Failure to comply with any of the provisions of the Act. Discipline, right? So if there's another discipline somewhere else, failure to provide information. And then we keep going down here. Knowingly false statements, aiding or assisting another person, violating any terms of order. Let's keep going to the next page. Signing, affixing. Again, if you're not responsible here, engaging in dishonorable, unethical, or unprofessional conduct, character to deceive, fraud, or harm the public. Habitual intoxication or addiction to the use of drugs or alcohol. It's in there. It's actually in there, right? To become an engineer in New York State, you need to have a good moral character. What's moral character? What do you define as good moral character? Some people define it differently than I might define it, but the state doesn't, there is a place for this where if you get a DWI or you get a DUI and it's maybe a repeat thing, I mean, like the first time you might be able to squeak it out and be like, hey, like, listen, like there's issues and whatever, but maybe you don't lose it right away. But honestly, the state has the right to be able to take away your license if you're doing these things, if you have a habitual intoxication. So as you're drinking a beer, oh man, well, hopefully you're still learning something, but that's great. So evidence of alcoholism, that's not great, but this is where it's kind of crazy. I mean, obviously people go through hard times. Maybe you have financial things that hit you, and you lose your home for some reason. We hope that never happens. Can you issue public opinions if they're based on facts? Yes, you have to be careful here. You don't want to get into the place where you're just issuing a whole bunch of things, even though they're just speculation. Again, that's where you got to be really careful about speculation, about public statements that are just kind of out there, but you're presenting yourself as this expert where you haven't actually done your due diligence to work it through. But this is based on facts, based on actual knowledge. Running for political office, you can still run for political office and be a PE. There's a congressman I remember that is a PE, I remember him grilling the head of the EPA when there was an environmental problem, saying, hey, did you have professional engineers working on this job, and the EPA saying, well, no, sir, I don't think we did. You know, and it's just, it's you can be a PE and run for political office. There's nothing against that. You can't bribe political officers. That's a different thing. That's why Spiro Agnew got, you know, resigned as a vice president of the United States back in the day. Okay, so let's keep going here. Contracts and contract law. This one's not going to show up in the reference handbook, but this kind of gets into construction a little bit, and I just thought I'd throw this one out there. 3 main requirements necessary for a valid contract are typically design, bid, build. Okay, no, that's a contract delivery method. Offer, acceptance, consideration. Okay, so somebody makes an offer, it's accepted, and there's consideration. There's some financial or monetary provision that says this is what's going to be paid, and we're going to exchange that. Okay, I like that one. Let's keep going though. Design, solicitation, bid. What's missing here? So the design was done. Somebody asked for a price was given, but until it's accepted, until there's, you know, money passed back and forth, it's not actually a contract. Okay, and let's keep going. Solicitation. So you ask for something, somebody makes an offer, and then somebody builds it. Well, just because you made an offer doesn't mean you have a notice to proceed, doesn't mean you have a contract, doesn't mean you've actually agreed on that offer. So the correct answer that I'm going to go with here is B. You offered, you accepted, and there's a consideration. There's consideration in terms of what financially is going to be exchanged, and that's exchanged as well. Okay. Question 10, and then we're just done with ethics. We'll send it. But this one is another one of those ones that I wanted to throw in here because this can be something that gets interesting when you get into the work world and budgets get overrun, and somebody says, okay, we're going to just charge our time to a different project, and it doesn't matter, nobody's going to be heard about it, but is it ethical? So engineering firm X here holds professional services contracts with private companies. They're not federal companies, they're not state companies, Y and Z. So firm X has contracts with Y and Z, and the project work at firm X has exceeded the budget for company Y. So what does supervisor A do? He wants a bean count. He says, okay, well, let's bean count this way. We're going to take the money or the time you work and go charge it to company Z, even though you're working for company Y, because company Z is under budget. We got money there. We can pay you from that one, right? Ah, man. So select all the following that would be considered an ethical approaches for engineer B. So what should engineer B do? What should you do? I mean, honestly, this might happen to you. You're working on a project. You says, okay, just hold on a second. That project's over budget. Take your time. Put it over here. What do you think? Just do it and get along and get your bonus at the end of the year because all your projects were under budget. Ah, no, don't do it. Just resist, right? Don't do it. It's unethical. Don't do it. Okay, just charge time to company Y and just ignore him. I mean, like, the guy's going to get fired anyway. Let's just ignore him. Honestly, man, this is where if you knowingly know something that there's a problem, you need to say something, and that's where I'll need to find it in here somewhere. But it's if you know, you need to actually, you have a responsibility to say something, and that's the hardest thing. That's the hardest thing. It's you're not attempting to injure or maliciously or falsely, accuse somebody else, but typically there's an obligation to say something if you know of a problem. And let's look here. So if there's a material discrepancy or error or omission, if there's a problem, you should say something. So you're not going to intentionally try to injure or maliciously go against somebody else. But typically you're not making political contributions with the intent to get work from that. But let's look. Where is it? Here we go. Licensees having knowledge or reason to believe that any person or firm has violated any rules or laws applying the practice of engineering surveying shall report to the board. This is kind of a stretch, but it's licensees. Here we go. This is probably even better. Shall not partner or offer to practice with any person or firm that is known or that they know is engaged in fraudulent or dishonest business or professional practices. So you can't do it. You just can't do it. And that's where you can't really, you're kind of in this place where you can't really ignore it. I mean, the NSPE, again, if you're looking at NSPE, they kind of have a thing in there that says you can't do the fraudulent piece of it. It's the same kind of idea. You kind of have a little bit of an obligation there. I'm going to say you can't just ignore this. You've got to address it. And that's where this third one kind of comes in. What you're doing is you're charging the company, you're charging the time the correct way. You're communicating your concerns and telling them no. And if the supervisor doesn't listen, what are you going to do? You're going to go up the chain of command. You're going to tell the firm principals if there's no change. So I think you do need to say something. You can't just ignore it and go along. And then this is the hardest one. If you're convinced that supervisor A doesn't care and you're convinced that firm X doesn't care, ultimately you have an ethical obligation to do something. I mean, this is ethical to document the process, resign from the firm, and report it if you need to, right? So this is where that can be ethical. Is it ethical to just go to the press? No, I don't think so. This isn't harming. This isn't harmful to the health, safety, welfare of anybody. This is, I say, the welfare of the public. In terms of a safety issue, this is a business practice that I think is worth kind of addressing through the code of ethics, not the press. I would say no to this last one. But what else? Is it ethical to just contact company Y&Z and say, hey, I'm working for a bunch of goons over here, and they are fraudulent, they're ripping you off, so why don't you just give me the contracts? That's not good either. Why is that? Because you're taking proprietary information from your first firm, from firm X, and using it for your own benefit with these other companies, and that's not okay either. So I'd say the middle two are your kind of reasonable approaches here. Okay, ethics. Oh man, honestly, you could probably argue with me on some of these, and I could probably go back and forth with you and change some of my answers here. Okay, ethics is tough, but it's one of those things where the best thing you can do is just read through that section, think about some of the different pieces here, and hopefully make it work. Okay, but hopefully they're just things you can logically think through, make sense of, and get right on the test. So there's not like a ton of training in the sense that you can take courses and courses on ethics, but most of you have a credit or 2 credits where you're dealing with some sort of professionalism, professional practice, ethics type of thing, and it gets in there. But one of the things that I love is when I present some of this stuff in one of the classes I teach, we talk through the Spiro Agnew case study, and actually one of the guys that's there brings up this idea of charging time incorrectly. He brings up the idea of what you can do as an engineer. And one of the things he says that I love, he says, keep your moral compass pointed north. And I love that illustration. It's one of the reasons, actually, if you look at my logo even, right, this logo up here, one of the reasons I use the north arrow, right, the civil engineering north arrow, it's just this idea of, you're going to be working, yeah, you want the technical piece to be right. You never want to forget your north arrow on your drawing. But also, I mean, keep that moral compass where you're working. Keep it personally. Keep it pointed north. Keep it pointed in the right direction, and it'll generally, it doesn't mean it'll go perfect. No, you may need to resign from your firm, but in the long run, I think you'll be a better engineer. You'll be fulfilling your obligations a lot better, and I think the public and you yourself will be more personally fulfilled in doing that. So that's where I'm going to end with ethics, and we're going to transition here. So I know we could probably spend a lot more time. Maybe I'll do another follow-up series here with just some general ethics kind of guidelines, because I think that'd be fun, honestly. And there's not a lot out there, but who knows? We'll see how that works out. But this is kind of where we're going with this. Take a look at the stamping issues, look at the licensure aspects, look at some of these kind of basic aspects of conducting yourselves in a reputable way, and I think you'll be able to answer these questions. Okay, I don't think they're going to try to trick you on things. I think they'll be questions that if you use some common sense and some business sense, you'll be able to make it work. If you use that Control F with keywords, you'll be pretty good. All right. So that concludes kind of not our whole night, but that concludes the ethics section. So what I'm going to do next is I'm just going to switch over here, and we're going to go to engineering economics, where I put together another 9 problems here on engineering economics, and hopefully this will be fun as well. So engineering economics has 4 topics: time, value, money, cost, analyses, and uncertainty. So this is 5 to 8 questions total. Some of you, I think most of you guys that I'm seeing online here have taken an economics course, an engineering economics course. I know some of the civil engineering students in our program do not have to take an engineering economics program. The civil engineering technology students do. So there's a range, right? But what we have here is, let's just start with time, value, of money. And this is one of my favorite examples, because if you want to put away $6 grand a year, guess what happens, right? This is one of those questions where in engineering economics, basically there's different ways of looking at this. Typically, most of the time what we're doing in economics is we're using some line diagrams. So we're saying, okay, this is year 0, we have year 1, year 2, year ... all the way up to like year 29 and year 30, right? So what we're saying here is, in year 1, we're going to put in $6,000. In year 2, we're going to put in $6,000. We're just going to keep doing that for 30 years, right? We're going to put in $6,000. And this is where in engineering economics, you can go through and 1 plus I to the n, all of these, but that works in a spreadsheet. It doesn't work here. So what we're going to do here is we're going to say, what we have is we're going to use these factors. We're going to say we want a future value. We want the amount at the end. So the end is going to be essentially this future value that we're taking out, F, right? So we want the future value at 10% per year. So that's this 10% per year over a 30-year period. And this is where, honestly, what you can do here is you can come to the FE reference handbook, and this is going to give you some of these interest rate tables. And these tables, if you haven't used them before, you definitely want to figuring out how to use them. But what do we have? We have the present given a future value. We have a present given an annual increment that gets put in. And this is where we have a future given a present, or a future given this annual investment. So we're going to come to future, annual investment. We want to go to the 10% table. So let me come down to 10%. And future given an annual payment, and we have 10%, 30 years, and we get this 164.4940. So actually what I could do is I can come back here, and sorry, let me get back here. And we get this value of this factor is essentially 164.490. So when we come down here, essentially what we're going to say is our future value, F, equals our annual installment times F given A for 10% interest over 30 years. So what does that look like? It basically looks like this: $6,000 times our 164.490, and that works out to be $986,940. So that works out to be just about $1 million bucks. Okay. So the cool thing is you max out your Roth IRA contribution, and by the time 30 years rolls around, you're hitting, if you're 20, 25 now taking the FE, 30 years later, guess what? You're going to be 50, 55 and a millionaire before you even hit 60. And you might be saying, yeah, but Mattson, that's a millionaire in today's dollar. That's a million in 30 years from now. It's a millionaire in 30 years from now. A millionaire isn't going to be like a millionaire like it is today. And I'll say, I agree. So let's look at question 2. Question 2 says, you have bigger aspirations. You want to be like a millionaire like you'd be a millionaire today. So the question is, you want to be a millionaire, but you want to have the equivalent of $1 million in today's money in 30 years. So what's that going to look like? Well, we're going to assume that we have an investment rate 10%. So this is kind of like stock market rate. We're going to do average inflation at 2% per year. And the amount that should be invested annually is most nearly. So in other words, let's take a look at a couple diagrams here. But the first thing that we want to do is we want to figure out how much $1 million will be worth in 30 years, or figure out, sorry, how much $1 million is worth in 30 years. Okay, so in other words, we're saying if we have this diagram, right, and we have this diagram, we're going to put in, or what we want is a present value of, essentially, we want a present value of $1 million. What's the future value going to be? So if this is times 0 and times 30, right, what is that going to be? Okay, and what's our interest rate here? This is where you have to understand the interest rate that we're looking at is inflation, right? So essentially what we're going to say is we want to look at this future value for f given p. So we have a present value. We know our present value. We're going to look at 2% interest because that's inflation. And right now it's closer to like 2.5 or 3%. But that number doesn't show up in the reference handbook. So we're just going to use 2% for 30 years. Right, and let's go look that up. Okay, so if we come back to, let's go to the reference handbook here. It's a little bit quicker. The engineering economics section is right before chemical engineering, and if I keep coming down here, I'll eventually get to a 2% rate table. I'm going to say f given p for 30 years is going to be f given p is going to be 1.8114. So I think that was a 1.8114, right? So in other words, our future value here equals our $1 million, which is our present value, times this factor. So times the factor of 1.8114. So in other words, in 30 years, a millionaire today is going to be like almost like a 1.8 millionaire in 30 years. So 1,400, right? So the equivalent of being a millionaire today would mean you have closer to 1.8 million in 30 years. Okay, so maybe that's what you're going to shoot for. You're going to shoot to have 1.8 million in the bank in 30 years. Well, how much do you have to put in? Obviously, if you want 1.8 million in the bank, you need to put in more than 6,000 because 6,000 got you to just about $1 million. And what's this going to be? I mean, we could just double it, but if we double it, does that put us to 11 or 13, right? Essentially what we want to do next here is this kind of becomes a two-step problem, right? Well, we want to figure out the annual investment, right? So in other words, again, what we have going on here is if we have this line diagram, right, what we want is we want to put in, if this is times 0, we want to put in some value a, you know, at 1, at 2, at ... all the way up to 29, all the way up to 30, right? We're going to be putting that in, that investment A in every year, okay? And at the end of 30 years, now we're going to have this F value of 1.8 million. Okay, so what we want to figure out is now we want to say, well, A equals what? It equals this future value times the future value times the factors. So the factors, we want A given F now at 10% in 30 years. Does that make sense? So we're saying, okay, this is going to be, we want this A value, but we have the future value because we inflated that by 2% for 30 years. We get this value. Now we want to get back to the actual amount we have to invest. So let's go look up this factor. Okay, so we want to go to the 10% table. So this was the 2% table. We don't want to stay there. Let's keep going until we get to the 10% table, and not too far. The 10% table, we want to go to, what do we say? We want A given F, and we want 30 years. You'll notice the bold ones are like the 5-year increments until you get to 25. And so if we come right under the bold, it helps us just navigate this table a little bit. We're going to do 0.0061. Okay, so we come back and we say, this factor here is 0.0061. We're going to say the 1.8 million, you know, 1.8 million times our 0.0061 is going to give us the amount we need to invest every year. So if you want to actually become kind of the equivalent of a millionaire, what does that mean? 1811400 times 0.0061. You're going to need to invest about $11,000 every year. Okay, so is that doable? Yeah, I mean it is. I mean 6,000 is a much easier target. So, you know, maybe you start at 6, maybe you work up to 8 or something. But the idea here is you're investing in yourself. You're investing in your own retirement. And honestly, a lot of times, if you start a job and you go get your job, ask about the employer match, because a lot of times you put in 3%, they put in 3%. There's something, you know, like that. There's options where the employer will do a profit sharing. Look for ways to get that $5,000, $6,000, $10,000 a year into a retirement savings account if you can. Maybe you buy or use a slightly, you know, less expensive car, but it's gonna be a great way to invest for your future. So hey, Cosine, I saw you there. Good to see you, man. We gotta let me know how you work out for jobs. I have people calling me about you. So let's keep going here. Question 3. A piece of equipment will have an initial cost of, so this, now we're into cost. So we're just in time value money. Cost. A piece of equipment will have an initial cost of $125,000 to purchase. Assume that maintenance costs will be base level $2,000, and then they'll increase $500 and keep going that through year 10. The equipment will have a salvage value of $12,000 after 10 years. Using an interest rate of 8%, the present worth of the equipment is most nearly. So again, this is just looking at how much is something going to actually cost. And let me start over here. Let me just make this line diagram where we're looking at, we know we have a sunk cost here of $125K to start. Okay, so we've got 125. This is year 0. This is the start. Okay, we get up to year 10, right? And we have a salvage value where this thing is still worth, we're going to get 12 grand back out of it. Okay, so 12K. And then we also have to put in our maintenance costs. So we're going to start with, you know, in year 1, we're going to have 2K, and then we're going to go to 2.5, and then we're going to go ... all the way up till, I think this works out to be about 6.5K at the end. Okay. And so we have a couple things going on here, and basically what we have going on here is we have to look at the present value. That basically we're trying to find the present worth of the cost. So how much is this actually going to be costing? We have to do some discounts, and we've got some values that are getting put in. These are the costs. I'm going to make these positive. This actually is a value that comes out. I'm going to make this negative the way that I'm going to do my Sine convention, and maybe you learned it a different way. But basically we're going to say the present cost P equals what? Well, it costs $125,000 to start. That's you know what it costs. It costs 125K. Okay, but then what else does it cost? Well, there's these maintenance costs here, and these maintenance costs I'm going to actually break up. I'm going to say part of the maintenance costs are going to look like this. We're going to have a constant cost of $2,000 every year. Okay, so this is a constant cost of that $2,000. And this one is going to be essentially we're going to look for a present worth given an A, and we're going to say what's our interest rate? Our interest rate's 8%, and we're looking at 10 years. Okay, so this is kind of the first one. We're going to take that A, you know, that A value of $2,000. We're going to multiply it by this factor, and we'll go look up factors in a minute. And you might be thinking, well, what do you do with the 500? Okay, what we do with the 500 is we say, well, that's a gradient, and essentially we're going to start with this gradient, and we're going to basically come to 0.5K since we're using thousands here, and then we're going to go to 1K, and then we're going to go to ... all the way up to essentially 4.5K at the end. So this is where we have that gradient that kind of starts, and moves up as we go. So this one we're going to look at, and we're going to say, okay, this one is kind of going to be like, we want a present given a gradient, right? And our G value, basically we're going to take our G, our gradient of $500. We want a present given a gradient at 8% over a 10-year period. So we can come back to our costs, and with this cost, that's essentially what we're doing. We're saying, okay, our present is going to be a combination of the direct cost plus all the maintenance costs, which is going to be plus A times P given A at 8% for 10 years, plus what else? The gradient cost of P given G at 8% for 10 years. And then the last thing here is we have this $12,000, right? So this $12,000 is a salvage cost. So we're going to take the future value times what we want is the present given the future value of 8% at 10 years. And one of the things that you have to be careful here is these costs are all adding up, right? Because these are all costs. This is actually a benefit. This is something you get back. And what we're going to do is we're going to actually subtract that one. So let's go look at factors and take a look at this. So aside from me, I hope you passed. Let me know how it goes, man. I'm serious. I so hope you passed. So let's come back here and come back to our chart, and we are at 8%, and let's get a couple factors. At 8%, I'm just going to tell you what they are, and then I'll go write them down. I think I have them written down here. But the first one we were looking at was P given A, so we want the present value given A at 10 years, so we're going to say 6.7101. We want P given G, so we're going to use the 25.9768. And then we want P given F of 0.4632. So let me come back. I'll write those in and we'll make this work. So I'm going to keep my 125,000. I'm going to say my annual, which is going to be 2,000 times the P given A was 6.7101 plus my gradient, which is going to be 1,000. And I'm just keeping this in thousands for now, just because it's 3 less zeros to write every time. But that was 25.9768. And then we're going to subtract here the 12,000 times the factor of 0.4632. So this P, the present value, hopefully I did this right, but I double checked it, so I normally haven't been making too many terrible mistakes. I make them every so often for sure, and if you've ever taken my real class, you know that I can make all sorts of mistakes. But let's see what we get. Times 25.9768, and then minus 12 times 0.4632. So I put all that in, and I hope I do it right. And I got about 145.85K. Okay, which translates into a total cost of about $146,000. Okay, so I think you get this value if you add the 12K instead. Okay, so that's where we go. But yeah, this is where it gets complicated. Okay, but this is the total cost. This is where it gets complicated, and yeah, you have to take a look. You have to look at all the different pieces in order to make it work. You got to be careful with these signs. But essentially, you can go look up these factors, and somebody out there is probably saying, "Why are you looking up factors? Why aren't you just using formulas? Isn't this the age of like the computer?" And the answer is yes, it's the age of the computer, but we still have sine and cosine tables. You never use them anymore because you have a calculator that does sine and cosine tables. These ones, I don't think these are in your calculator. So there are formulas for all of these. You can go make these tables yourself, right? But if we look at the formulas, they're just ugly. Okay, these formulas here are ugly, and you don't want to be screwing up these formulas on the FE, right? So I mean, it's just like, I don't want to put that in my calculator. Did I put it into Excel? Actually, I did. Actually, no, I put which one did I put in? We did the uniform series present worth, I think. I put a bunch of these into Excel just because I wanted to double check things. So, you don't have to mess with these formulas most likely, but they're there. This is the most basic form, the 1 plus I to the n. That's the future value given the present, right? So that one's an easy one. You could plug that one in. But in general, when you start getting into weird things like this, the tables really, really make it a lot easier. Okay, so let's go to question 4, and let's look here. We have interest on loans 8% compounded each month. So normally we see things that are compounded annually, okay? So what are we going to do? We're going to say, what's the effective annualized interest rate? And so what's the total annual interest rate? And it's going to be more than 8%, because when you compound it monthly, you start adding interest on top of the interest, and that's why you want to start investing early, because the more interest you get, the better off you are. And I did hear it said that there's two types of people in this world. There are those that make interest and those that pay interest. You want to be one of the ones that makes interest. So, man, life lesson. I don't know. Can I say try to stay out of debt? Sure, I'll say it. Why not? So try to stay out of debt. It's if you can be one of those people that makes interest. Not everybody can be Elon Musk, believe me. But if you can be one of those people that makes interest, I would totally recommend it. I think it's if you can get your finances wrapped around that, that's a great way. So let's look at this. The reason I threw this one in here is because there's a formula for it. Honestly, there aren't a ton of formulas past those other kind of crazy formulas that they also have tables for. So if we look at this, right, there's like a couple sheets here and then there's tables. So there's about 2 pages of formulas. One of them being the non-annual compounding. So M can be months, it can be quarters, you can do kind of whatever, but I'm just going to use this formula here and make it work. So basically this one is a fairly straightforward, but i.e. the effective rate is going to equal 1 plus R over M to the power of M minus 1. So that's the formula you're given, where R is what? R is the annual rate, essentially, annual rate. M is kind of the non-annual term, right? The non-annual term. So what are we going to do? We're going to say, well, I sub E equals 1 plus the rate of 8% divided by 12 to the 12 minus 1. Okay, so all we're doing here is we're plugging that in. And when you plug that into your calculator, be careful because it's actually really like 1 plus 0.08 over 12. Don't use the number 8 over 12 because you'll get the wrong answer. I should have thrown that one in as one of the bad answers, but I didn't. So when you do this out, I think you get essentially about 8.3% or 0.083. Okay, and so that one should work out without too much difficulty. That's just a plug and chug. I mean, I wish it was. I don't wish it was more complicated. If you get something like that, I hope it's that easy. Okay, will it be? I don't know, but it's one of those things where honestly, I think this isn't like algebra 1 or algebra 2. Like in like if you're looking at Common Core stuff, this is high school type of rates, and it's confusing. It's confusing, no doubt, but it's something that I think you can do. All right, let's go to question 5. And question 5, we're getting to a piece of equipment, and we're looking at costs again. Sometimes recovered costs, so you can look at that as depreciation, and there's different ways of looking at that. There's straight line depreciation, so in other words, your depreciation just goes down in a straight line. And then there's an accelerated, modified accelerated cost recovery system, right, MACRS, which is another system. We'll look at both of them, and the reason we'll look at both of them is because both of them are in the FE reference handbook. So we have depreciation here, we have straight line, we have modified accelerated cost recovery, and basically what we're doing here is we're saying, well, you all know this, if you buy a new car and you drive it off the lot, you can't turn around and sell it for what you just bought it for. Why? Because there's such a steep depreciation when you first start. So the accelerated basically takes that into account and says, okay, we're going to do more depreciation right up front versus having a constant amount of depreciation every year. Okay, so you can look at both of them, but the basics here are what? We have a piece of equipment, initial cost $120,000, expected to have a salvage value of $15,000 after its 5-year service life. It's depreciated using the straight line method, and the equipment's book value at the end of year 3 is most nearly. Well, what do we have? First, we have to find the annual depreciation. So what's that? Well, the formula that was from the FE reference handbook says the annual depreciation is equal to the cost minus the salvage value, essentially, over N. And so what do we have here? This is just kind of plug and chug, 120K minus 15K divided by 5 terms, and I think that works out to be, well, actually 5, I could put in years here, right? Because what this works out to, if you actually keep the units, is going to be $21,000 per year of depreciation. Okay, so the second thing that we want to do, though, is find the book value, right? So what's the book value? The book value is basically what you could sell this thing for at the end of 3 years, right? So at the end of 3 years, what are we going to do here? We're going to say the book value is the initial cost minus the sum of DJ, so the sum of your depreciation, whether it's straight line or modified accelerated cost recovery. All right, so here we're going to say the book value equals the cost, this original cost, minus 3 times 21,000, per, these are all K's per year. And so the book value is just going to be straight up. We're just going to do 120 minus 3 times 21. And what's that going to be? 57K. And why do I leave those zeros off? Just because it's fewer numbers to punch in the calculator, right? Does it save you a little bit of time? I think it saves you time, but more importantly, I think it saves you error, because every key you have to push into the calculator, if you hit wrong, it screws you up, right? So if you can save some of those numbers from pushing in, it helps. Also, when you put in fewer numbers in the calculator, you can see all of the numbers in the screen, right? So if you can see them all, it makes it a little bit easier. So sometimes I kind of prefer to do it that way. But, if you like adding all the zeros, by all means add all the zeros and you will get the same answer. Okay, so let's keep going to question 6, because this is also a depreciation problem. And what we have here is a piece of equipment with initial cost of 120,000, salvage value 15,000, same cost, same salvage value, 5-year service life. The only difference here is we're using the Macrs method, right? So the depreciation charge for year 3 is most nearly. Well, if we were to ask this question up here, we just say, well, year 3 is going to be 21,000. But what about Macrs? Macrs, this is a system that's used by the IRS to account for the costs and recover the costs based on depreciation. And if we come down here, we can basically have a Macrs factor, and we can look, and there's a recovery period of 5 years. We come to year 3, and you'll see for year 2 we have 32% recovery. Year 1 we have 20% recovery. Why is that? Does anybody have any clue why do we start in year 1 with less recovery than year 2? That doesn't make sense. When you first drive that car off the lot, it should drop more, shouldn't it? Well, it should. Okay, and the reason that this is less, and the reason you end up with a year 6 on a 5-year recovery, is because the Macrs accounts for, it basically says we're going to start July 1st of that year. We're going to start in the middle of the year, so you get half a year of depreciation. So you start with a half year of depreciation from the middle of the year to the end of the year, and then you get a full year of depreciation, then you get a full year of depreciation, and then you actually go to straight line depreciation for what's left. So you'll notice the 11.52, and then the half year is half of the 11.52. Okay, and that's kind of constant here as well. So at some point you go to straight line depreciation, and then you go to that extra half a year. So straight line depreciation, extra half a year. Okay, but the first part, that's going to be kind of the accelerated piece where you're going to get more. So year 3, we're going to use this 19.20 for our factor. And actually, if I come back here for a second, the modified accelerated cost recovery says the depreciation is going to be the factor times the initial cost. You don't subtract the salvage value here like you did for the straight line depreciation. So for Macrs, you do not. You just take the full cost. So let's take a look at that, and we're going to say that D of 3. Sorry, no, we're not doing DJ anymore. We're doing D3 equals the factor times C. So we said that factor was 19.2, and that's 19.2% of 120. And why not? Let's just say K. Okay, so what's that? 0.192 times 120, and I get about 23.04 thousand dollars, or 23,040 dollars. Okay, and that's going to be our depreciation in year 3. So the modified accelerated, the Macrs is the one that IRS uses. It goes to straight line after, in this case, after so many years. And that half, that extra year, is because it's shifted. So you start in the middle of a year and end with another half a year at the end. Okay. Let's keep going. Just a couple more questions, and we'll see. So it's question 7. What do we have? A solar project expected to have an initial cost of $2 million. So is it worth it? Should we pay $2 million? Is there a benefit? In this is a benefit cost analysis. This is one of those ones that shows up in the FE. Actually, right, where did it go? I thought I just saw it here. There's a break-even analysis. We'll do one of those. And actually, it's on the depreciation page, but we have a benefit cost analysis that we're going to be looking at here. So essentially, you want your benefits to be bigger than your cost, right? You want your benefits, what you get back, to be better than what you have to put into it, because otherwise you're just paying for Twitter. So sorry, I don't know. Maybe Twitter's a good thing to pay for. I don't know. I'm not going to get into that, but I'm not an expert on Twitter, so I'm not even going to go there. That's just all satire. So let's just keep going here. Sorry. Let's do our benefit cost analysis. I got to be careful ethically, you know. You can't make comments. But I don't know what the. Okay, we're just gonna keep going. So let's do our benefit cost ratio and see what we get. So let's look at this and say we have a project, right? And we have this project. We have 25-year life cycle. So we're saying we're putting in $2 million. Okay, that's our initial upfront cost. What else do we have? We have profit, or we have cost of $50K a year. And so every year, we're just saying it's going to cost $50,000 to go maintain this, right? Whether it's mowing lawns or it's, you know, changing panels or whatever it is, we're going to add $50,000 every year for the life of this. Okay. So what you can see here is these are our costs, right? And what's our benefit? Our benefit is going to be at the, you know, at each year we're going to take out $250,000. So we're going to get that much energy out of this, assuming that the sun shines and our models are correct. Okay, so we're going to get $250,000 every year. Okay, from essentially from 0, 1 to all the way up to 25. Okay. So what we want to do is we want to come up with essentially values for each of these. So we want to come up with the benefits, and this is going to equal what? It's going to equal, well, we have an annualized cost here. So what we're going to look for is we can bring this all back to the present. But what we could say is, well, we're going to spend we're going to get in $250,000 every year. So what is that? That's an annual. I'm sorry, we have an annual, but what we want to get is we want to get our present worth. So our present worth given an annual at what's our interest rate we're using? We're going to use 8%. Okay, over a year, over 25 years. So those are the benefits. A good time to invest. Oh man, so what are the costs? The costs are going to be, well, we have 2 million. So 2 million, and now I'm going to use all those zeros. Okay, and that's just a cost. That's a straight up cost. There's no factor on that. But then what else are we going to have? We're going to have $50,000 every year. So here I'm going to sort of mix and match. I have my K up above and no K's down here. But what's this? This is, again, we want a P given A at 8% for 25 years. So these two factors are going to be the same, right? These two factors are going to be the same, but we can make that work. And if we go look at that factor, we want that factor. So what is it? We're saying P given A at 8% for 25 years. We can go find that factor. And what is it? So we got 8%. And let's come to the 8% table. There it is. 8%. We want P given A, 25 years. So it's 10.6748. Okay. So we got 10.6748. That's going to come, you know, down here and down here. And when we plug those in, we're going to get some values here. So for the benefits, I'm going to get basically what, 250, 250,000. I'm going to add in all those zeros times 10.6748, and I get a total benefit of 2,668,700. Okay, and my total costs are going to be 2 million plus what? Plus 50,000 times that 10.6748. So my total costs are going to be 2,055,33,740. And essentially all that we're doing here is we're doing our benefit to cost ratio, right? And if we look back, you want the benefits on top, right? So if we look back here, right, we come back to our benefit to cost ratio. We want B over C, so we want benefits over the costs. And what do we get? So if we divide those two numbers, they're both in the calculator. It's easy enough to do. Just one divided by the other. We get a value here of 1.05. So is it profitable? Yeah, a little bit. Okay, but this one you have some profit, so it works. So definitely. It's something to consider. Does it, if these were a little bit closer, you're going to break even. Is there a lot of margin there? Though? No, there's not a lot of margin. A lot of times you want a higher rate of return on your investment. But should you break even? You should, unless you made a mistake somewhere, like in how much you're going to sell the energy for, or how much it's going to cost to maintain it, right? So there's some risk that gets associated there, but there's also some rates of return. The rate of return on investment is the interest rate that makes the benefit and costs equal. So we could take a look at this and say what interest rate here will make the benefits and costs equal, and am I willing to accept that rate of return? And if so, then you're good, But so yeah, this works. This works for an 8% rate of return. You still get even a little bit above that. Okay, so another kind of idea there. Let's go. We got 2 questions left. And here, question 8, we've got 2 alternatives are considered for procuring a part. So this is another one of those analyses, but if we come back to the reference handbook, one of the analyses here that I think I saw was a break-even analysis. And basically what we're doing here is we're saying, if everything else, where do we break even? What do we need to do to make this equal? There's a couple different types of break-even points, but one is like, what's the payback period? What period of time to finally get to profit? Another way of looking at break-even is saying, if we've got 2 different approaches here, when if this, for example, in this one, we say we want to just buy everything. We're going to buy the equipment. We're going to get we're going to have a salvage value at the end of this, where it's going to cost us some money to operate it, but it's going to be cheaper to produce each part. So it's going to cost us $100,000 to make or to get the equipment. We're going to get $5,000 back from that equipment at the end of its life. Not much, but we'll get something back. We're going to spend $15,000 a year to use the equipment, but parts only cost $18 a part. So how many parts, are we going to make where it makes sense to make them in-house versus how many parts does it make to go ship them? If you're buying one part, obviously it makes sense to pay $32 and get rid of this, this value. But I mean, this is kind of like the idea of what you've got one equation where you have it, like if this is, method A, right? If this is method A, you've got one equation where you have some high kind of startup cost, but then a lower slope, right? This slope would be like what, $18 a part, versus you have a kind of a higher version here of $32 a part, but you have 0 startup cost, right? So this is kind of like our 2 methods, and what we want to find is, what is this value, right? So what is this magic value X where we have a break even? So what does this look like? You got to write 2 equations, and you got to set them equal to each other and solve for X, right? So let's do that. Let's look at method A, and we'll say, okay, well, method A, what is method A? Method A, what we're going to do here is, let's look to see, we have parts required per year, so let's bring everything to an annualized cost. Does that make sense? So we want to figure out how much these parts are going to cost every year. So we're going to look at the parts, or the cost per year. So method A, we're going to say, well, the annualized cost for A are going to equal, well, we have this whole startup cost thing, $100,000 times what? Times A given P. So we're given a present value, but we want the annualized value for that. What's our rate of return here? We're saying we have 8%, and we have a 5-year life. Okay, so we just took that $100,000 initial startup cost and we annualized it. And then what's next? Plus, we have to add in our $15,000 per year. Those are our maintenance or operations costs. And then I'm going to subtract off my future 5,000 salvage value times A given F at 8% for 5 years. And what else do we have? every year we have to pay plus what, 15, no, not 15, we have to pay $18 per part. And what I'm going to say here is I'm going to say let X equal the number of parts produced or needed each year, produced / needed each year. So what's this? This is $18 per part, so 18 times X. Okay, and then if we look at B, we look at method B. What are we going to say? Well, our essentially our annualized costs for method B are just going to be 32 times X. Right? So all we have to do now is we have to essentially set A equal to B, and we can solve for X, right? So what we want to do is we want to set, A sub A equal to A sub B and solve for X. Okay? Well, to do that, I'm just going to find my factors here first. So I'm going to find my factors for A given P, 8% 5 years, A given F, 8% 5 years. So let me come back and go to my 8% tables. So A given P, we're at 8%, A given P, we want to be the 5-year table, I think we're at 5 years. Yeah, so we got A given P is 0.2505, and A given F is 0.1705. So I'm going to come back here, I'm going to just write those in. Let me write it in. A given P was 0.2505, A given F is 0.1705. And I'm going to just write this in. I'm going to, if you put this into your calculator, you should get out essentially $39,197.5 plus 18X. Okay. And we know that has to equal A sub B, which equals 32X. Okay, so if we set those two equal to each other, we should be able to solve and say that X equals, what is this? It's 32 minus 18. So 32 minus 18 is going to be 14. So basically it's what, 197.5 divided by 14. So I got like basically $2,800. Or I'm sorry, not $2,800. 2,800 parts. So if you need 2,800 parts, if you need 2,801, if you need 3,000, if you need 5,000 parts, it's cheaper to buy the equipment and do it yourself. But if you need less than 2,800, it's cheaper to just go buy them. Does that make sense? So that's kind of the break-even point here, is we're going to say 2,800. Okay, does that make sense? So hopefully that makes sense. But again, it's just kind of thinking in terms of what are we actually trying to do, and with this, I hope this picture makes a little bit of sense, because we have two linear equations and we're just trying to find where X is. So if you go back to the math review, this is basically the same thing, but you have to add in these factors here for the economics piece. All right, last question of the night. Actually, it's not the last question of the night. I got a special question for you after, so keep on. I gotta, I won't spoil it, but we got a economics question. That's a special one. So what do we got? We got 4 levels of quality being considered for equipment to produce a part. The initial cost and repair cost and probability of equipment failure in any given year is presented in the table below. So we're doing uncertainty analyses, and sometimes you have these percentage of events that might occur. And if the event occurs, then you're going to have a percent cost that gets added on. So where does this show up in the FE reference handbook? This shows up, and I think it's right before we get to the tables. Let me just double check here. Right before we get to the tables, yeah, I went too far. Let me get back here. But we have expected value equals the cost times the probability of that cost, plus the cost times the probability of the next cost, and we just keep adding them on, right? So we have there's some decision trees you can make. We're not going to deal with those as much tonight, but the idea here is there's some things that can happen where there's different probabilities that you have to take into account. Like, for example, what we have here is the equipment. We want 10 years of use out of this equipment. We got an interest rate of 6%. but we have an initial cost of $50,000, a repair cost of $30,000. So even if you have to, buy the thing and repair it, you're still cheaper than the more expensive version. But where's the difference? The difference is the cheap one's going to fail 4 out of the 10 years essentially, right? There's a 40% chance of failure. So this one's going to fail quite a bit. You're going to have downtime too, but that doesn't even get included in here. We're just saying the initial cost plus the repair cost and a 40% chance of repair in any given year. That's a lot. So, but then does it make sense to do something in the middle where you get a slightly better quality, a slightly higher repair cost, but more quality here? Or does it make sense just to go full bore? Let's get all the quality that we can. It's gonna cost us a lot to repair it, but we're not gonna have to repair it as much. So what does this look like? Basically, this looks like we're not even gonna do too much here with factors. We're gonna have one factor, but let's look at this. We're gonna say, well, let's look at the expected value of A. What's this gonna be? In general, what we had was the expected value is gonna equal the cost times the probability plus ... right? It's just we're gonna keep going out like that. Okay, and basically here we got the $50,000 cost, which is our initial cost, right? And what's our probability of that? 1, right? We know that we're going to be buying the equipment, so that's $50,000 plus what do we need? So each, but plus what we're going to do here is we're going to say, well, I'm going to say $30,000. Times basically what I'm going to say is let's think of this as like we're going to spend $30,000 every year. Okay, so I'm going to say P given A, so that's an annualized cost at 6% over 10 years. But there's only, this is where the probability comes in, there's only a 0.4 or 40% probability that we're going to pay that cost every year. So we get this 30,000, we say, okay, let's look at it as a cost every year, but we're only going to do it for 40% chance. So we're going to reduce that by its probability. So we do that out, and actually let's go find that factor. P given A, 6%, 10 years, and 6% P given A, 10 years, 7.3601. Okay, so 7.3601. And I'm going to get a value here of about $138,321. So over the course of 10 years, we'd expect about $140,000 for that option. Okay, so what does that mean? 50,000, you're going to have probably, what's that, 138 minus 50, so 138 minus 50 divided by 30. It's about 3 to 4, 3 repairs roughly. Depending on how you look at it for that annualized cost. Is it reasonable? Yeah. Well, what do we have to do? We just have to repeat this process for each one. Okay. So all that we're doing here is we're changing numbers, right? But we're gonna change numbers here. We're gonna say expected value of B. What's this? 75K. Times 1 plus what's this? 35. K. Times that 7.3601, times our 0.4, and I'm going to get for that one, I'm going to get 139,401. So the second option is a little bit more expensive, but not much more, right? Not much more, because that 25% is a lot better than the 40%. Expected value of B, what are we going to change? We're just going to change to 85K. Okay, times 1 plus 45K. Times the 7.3601 times the 40%, and I get a value for that of actually a little bit cheaper at 134 at 681. And then what we see here is that, sorry, this is C, and then for D, what are we going to get? We are going to get essentially the same type of thing here. So all that we're going to do is we're going to change numbers, and we're going to say 98K. Times 1 plus 50,000 times 7.3601 times our 0.4, and this one's going to actually be our best option. So it's 116,400. So increasing that quality actually pays off. So even though we're paying off we're paying quite a bit here. The probability of failure is so low that it's actually economically kind of the best answer. Okay, sorry, what did I do wrong? Thanks, guys. So yeah, so the probability changes on all of these. I appreciate that. 0. Oh man. So if you actually put these in here, right, 0.25, 0.15, and 0.05. Okay, thank you. I appreciate it. I did do the numbers right. I put them in. It's in my notes, right? I just it's getting late. So when we get these numbers right, the actual final answer here, that's going to be the best in this scenario. Does that mean highest quality is always going to be the best price? No, but in this case, it is. Okay. So that's the last of the published questions, and I've got one bonus question for you guys because you stayed on and have been through the thick and thin of all of this and the lags and the restarts and all that stuff. I might throw in just a bonus session on materials next week. In the past, I haven't done materials with this review course, so I might throw it in just as a bonus. It'll maybe next week or the week after, depending on when I get to it, but it'll be out there for you, and we'll see. So this is the bonus question, though, just for fun, and let's go to it. So we are going to say this is what this looks like. I have a question here for you, and the question is, I'm just going to come back here for a second. Who wrote the book, How to Get Rich? And normally I have a joke. This is sort of a joke, but it's sort of fun. So Cold Cash, I wanted to get Cold Cash in there, but it didn't really work. So I don't really like him as much. But he's one person that could write this. Mo Money. Why not? Mo Money. We could also have Pennywise, or my absolute favorite, How to Get Rich by Robin Banks. So yeah, so if you want to get rich, just make sure you read it by How to Get Rich by Robin Banks. And you should be able to get rich soon. But honestly, the best option is not to go rob banks, because that's a bad option. The best option is to actually go invest that 6 or 10 or 11 grand every year, and then you'll be a millionaire. So that's the best option. And if you find this book out there, let me know, because I'd love to read it. It's probably a good read. Actually, the funny thing is, there's a real author that's named Robin Banks. I don't think that that author's written this book, though, but maybe we should suggest it. So that's all I got for tonight. If you like this question, you can maybe give it a thumbs up or something, but that's all I got. So hopefully economics, ethics, hopefully they go together, and greed doesn't drive over top of ethics, right? I started with ethics because the point is you want to make sure you put the health, safety, welfare of the public first. We went through the economics piece of it, but I'm going to end and wrap this up with ethics as well, because at the end of the day, your job as an engineer is to put others first, right? Your job as an engineer to put the health, safety, and welfare of others first, even above your own interest at times, your own financial gain. And that's one of the things that I can't stress enough. It's the first code of ethics it's the first, canon in every code of ethics is to put others first, to put the health, safety, welfare of others first. So I'd be negligent if I just didn't get that out there, and I want to get that out there, because that's if there's one thing you remember about ethics, it's not the Robin Banks jokes. The one thing, if you remember, is just to put the health, safety, and welfare of others first. So hope that helps. I'm just looking at comments. No, nothing too crazy out there, but hey, for those of you guys that are in my real class, and I hope this helped. Definitely check in. Let me know when you pass this thing. I'd love to hear from you, even if you're not one of my students. It's fun to hear from you too. But Sammy, Mike, Noah, if you guys want to do videos later once you pass, just let me know. I totally expect you guys will 100% get this, and I'm looking forward to getting those emails that say you guys pass and hear from you. So maybe we'll see you next week. Maybe we'll do materials, but if I don't see you again, hey, there will be more content coming at some point. But until next time, guys, keep working hard and moving onward and upward.